Welcome back, guys. Now that all of you have gone through that Code Academy review of Python, so I think you should be pretty up to date on diving a little bit deeper into using Python, some of what you've learned, and maybe learning a lot more new stuff. So it should be fun. How can we use code to analyze data? Okay, now data analysis, whenever we deal with data, so typically what comes to mind is Excel. Okay, and quite a bit of what you would do, apart from building, say, production ready machine learning systems or doing some large scale data analysis, you could pretty much do that in Excel. The problem comes in Excel is when you're dealing with thousands and thousands of rows, okay, or a very big data set where there is and the data is not clean. Okay, and it would hardly be an instance in your life, in your day-to-day life, if you were to be around data where you will get a data set and you will be ready to go. Okay, so you will have to spend a lot of effort and a lot of time trying to clean the data set to be in a form where you can actually do some work, okay, or do some analysis on it. Okay, so why would you want to code? A lot of the data would have text mixed in, data mixed into text. Okay, so for example, you will have a text feed. Okay, and I'll show you an example. You might have a text feed where you might have to extract, say, numbers from that feed. Okay, yes, you could do that in Excel. You can go line by line. You can manually extract that information. Which is of course going to be prone to error and all, and the bigger problem is that it's going to take a long time for you to do that. Okay, that's why you would want to code around it. So why would you want to code? Apart from cleaning data, I think code in general, being able to code regardless of what you do in life, if you find anything where you feel it's a drudgery, okay, most of the time you could actually code around it, right? So you can automate some of those tasks. Okay, I do that, a lot of folks do that, and it's not that difficult. It's a lot of fun. It is frustrating initially, but as you do it more and more often, as you tackle more and more of these problems, it gets more and more fun, and it gets a lot more easier. Okay, so it's just like learning any language. Coding is a type of language. You tell the computer to do what you want it to do, and so it's a language. You just have to get used to it. Okay, and there is a moment around. I guess it's a good moment where a lot of this you hear it all the time that everyone should be able to code and all. Girls who code, and everyone must code, and so I think it's a good moment, and I think there is a reason why the next set of jobs, maybe say a decade from now, will involve a lot of, not even a decade from now, even now, but at least you can get by not knowing coding now, but more and more as time goes by, you would be expected at work, regardless of what you do, to sort of be able to do a little bit of these things. Okay, here is a quote by Alexis Ohanian. He's the founder of Reddit, or co-founder of Reddit, and Reddit, I think, is a news aggregation website. I keep coming across it. I don't actively go seek it out, but it's pretty popular. It's I guess a lot of folks use it, so I just wanted to quote it, and there are many quotes like this. Okay, so he's married to I think Serena Williams. I think one of the Williams sisters. Okay, I think it's Serena Williams. Okay, so going. Oh, I think before that I wanted to show you a scenario as to why you would want to code. Okay, so I am going to point you to this website. So there is this turbine.io website. It's a global exchange for data. Okay, folks who are collecting data, or at least the machines that are collecting data, all the sensors which are collecting data all across the globe, they are feeding that data sets, those those streams of data into this exchange. Okay, and you could download it, you can play around with it, and I think we, as the course progresses, we are going to use a couple of these examples to sort of showcase the power of being able to code and being able to analyze data. Okay, so here is this feed I was talking about. Okay, so this is measuring water levels in San Francisco Bay, San Francisco, California. Okay, and as you can see, so this is all the description of what it is doing, what this particular sensor or a series of sensors are doing. But as you can see, the type of data it is collecting, it's a stream of numbers. You see, it's not very clean, right? So if you wanted to sort of convert that into a spreadsheet, or if you want to extract, say, date, time, predicted feed, preliminary feed, verified feed, you can see that these are the columns, or this is the way how the data schema is arranged, or how the format of the data is. Okay, and each instance is measuring. So this is date, this is time, predicted feed. Okay, I believe this is predicted feed, preliminary feed. Oh, that's not available, so it's a dash. Verified feed, and so on, right? So you see, so that's how typically you would deal with data in the real world. Okay, so you cannot go in, and this doesn't end here, by the way. Okay, so this goes on for probably million instances. Okay, because it is collecting data every day. Okay, so that tells you that you cannot just go in and extract manually all this information, right? So that's why you would want to code around it, right? And as the course progresses, you will find out that it's not a big deal to sort of solve these kind of problems. Okay, so just a little bit of a sidetrack, going back to our slide deck. Okay, so let me turn that into duplicate mode. Okay, so what's the objective? Okay, as I said, I kept talking about it. So we want to be able to manipulate, aggregate, clean, and visualize data. Okay, why visualize? Okay, human beings are not good at just looking at a spreadsheet and being able to figure stuff out. Okay, so we need to be able to see that in a picture form. Okay, a plot is a lot easier to sort of see what is going on, okay, than reading a bunch of digits. Okay, so that's why visualization is a very important skill. We're going to get into that. We're going to use some of these libraries which are written for Python. Okay, so some kind folks have worked hard to sort of develop to build these libraries. Okay, so there is NumPy, Pandas, we'll get into that. Seaborn is a visualization library, we'll get into that. Okay, and there is R. Okay, so there are two different tool sets that are heavily used. So R came first from the perspective of doing doing a lot of statistical data analysis. Okay, so R has a pretty rich history, pretty long history of being around, a lot longer for the data analysis tasks than Python. Okay, but Python is catching up, so that's why, and specifically when you're dealing with being able to build something and deploy, I think Python is, deploy means let's say you want to analyze some data and you want to post it on a website. Okay, and that's what I mean by deploying. Okay, so Python is it's a lot easier to do that with Python than with R. Okay, but R, going back to R, it has one of the richest ecosystems to perform data analysis. Python is catching up, but there are around 12,000 packages which basically can do anything and everything to do with data. Okay, the reason I love to use R a lot, I use both, but I also use R quite a bit, and there is this library, or there is this package written by Hadley Wickham. Okay, it's a data viz package. That is, data viz is short for data visualization, and it can it can create some of the prettiest plots you can get. Okay, so that's why I like it, I love it. Okay, plots like this, for example, look at this. Okay, so I'm trying to figure a way out to do this in Python. I'm still not able to do it, but this is an example of a plot I was able to generate in R. This is one more, the same, different viewpoints, same set of data. Okay, we'll talk a little bit about what all this. So this is a particular data set I was analyzing. So we'll talk a bit about what large US equity. This is basically capital markets data, that is like stock and bond market data. Okay, so we'll have fun with this as well, a little bit of. So some house cleaning before we move on. Okay, there has to be. So we are going to use this version of Python or Python. Okay, so you'll have to install it from this website Anaconda. Okay, and all the homework and project submissions will be done using Jupyter Notebook. It's a pretty neat way to sort of analyze data, write text around, write stories around what the data is telling you, and potentially use that notebook to send it to whoever you are showcasing your work to, right? So for example, if you want to send it to your boss, you can do that. You can show it to your to management. You can send it to customers and so on, right? So I think this framework, this Jupyter framework, comes in very handy from the perspective of being able to analyze, write about what you are analyzing, create plots, write code. Everything comes into this one page format. Okay, so plus GitHub. Okay, GitHub is I guess you can store. Okay, GitHub is public. Okay, so you can store some of your work on GitHub, right? You don't have to do it, but I highly recommend it. One reason I do it is so let's say I'm working on a set of data I'm trying to analyze, and I figure a solution out. Okay, and by the way, a lot of the stuff you will be doing, there is no course design which will teach you everything. So you have to be an explorer. You have to be willing to go one step deeper, maybe a couple of steps deeper, and try to figure stuff out. Okay, and that's the fun part, right? I or anyone can be teaching you everything, right? So there is Google out there, there is Stack Overflow, which you will keep coming across when you are looking for answers to a particular question you might have around code, right? For example, how do I write a for loop, or how do I write this function, or how do I extract this information out from a code, right? So a lot of these things you do it once, and you want to have a repository. Okay, so that you can use it over and over again. And I use GitHub for it. I'll show you an example. Let me just click here. Let's see where it takes us. Okay, it takes us to GitHub. Okay, and I believe I'm already signed in. I'll show you an example of what I keep there, not for anyone else. It's just personally for me, but anyone can actually look at your work. So it could be a pretty good way to showcase your work as well, right? So I think I highly recommend. So some of these things, so for example, these are all loading. These are all different sets of problems I am trying to sort of analyze and work on. Okay, oh sorry, it says this can be loaded. This is loading. Okay, this is loaded. So see, I have all this code. So next time when I want to do something, and if it's something similar to what I've already done, I can just copy and paste code. Okay, so it's a pretty handy resource for me. Okay, and likely for you as well. Okay. Okay, so that was GitHub. So the Jupyter Notebook, so we just talked about it. We're going to have pretty much everything done using this, and you'll pretty soon get to see what it is. Okay. So it's an environment. So as I said, you can write code, text, plots, images, anything in a single page setup. You can write stories. You can write a book if you have to write a book, right? So each cell can contain code or text. Also, text is basically called, when you are in text mode, it's called markdown mode. Okay, just a nomenclature. Okay, and anytime you want to execute a cell, you just say shift plus enter, shift enter, or control plus enter. Okay, and it's pretty self-explanatory. We just talked about that you can write and execute code, and you can write text. Okay. Writing code is this way. We're going to get into that. So A is so 7 is assigned to variable A, 5 is assigned to variable B, and A times B is 35. Okay, so that's pretty. And these are some shortcuts you're going to use more and more often. Okay, A and B, A insert cell. So if when you have clicked this and you say A, you type A, is going to insert a cell above. B, it's going to insert a cell below, and we'll get to see that. Okay, and DD is delete, and so on. So okay. Yeah. So one quick thing: if your cursor is highlight, if you can see your cursor in that cell, you cannot use this shortcut. So you have to get out of the cell, and you have to pick this cell. Okay. So once you select that, you should be able to execute any of these shortcuts. Okay, there is this cheat sheet. A lot of this stuff is going to be available to you, so you can use this cheat sheet to get around Jupyter Notebook, but you don't need to do that. I think or what you have on these slides is more than enough. Okay. So writing text in markdown mode, we're going to get so these are some of the shortcuts for that. Okay. Okay, in markdown mode, it's going to look like this, and once you execute all the cells, it's going to look like this. So it's pretty clean, right? So okay, Python. Going back to Python. So Python as we just discussed, as you came out of that homework, so Python is the language of choice for this course, and pretty much anytime you have to deal with data and analyze data and all those things, right? You can also do R, as I said, but Python it is for now. Okay, so it's a high level programming language. Okay, so high level means, okay, so when you write code, right, though you think that code seems foreign, but at least you can go and read through that code. Okay, and you can sort of try to make some sense out of that code. But once that code is executed, there are a series of steps which happens where that code, that human readable code, has to be translated into a machine readable format where your machine or your computer can understand. Okay, so that's what I mean by high level programming language. And it's interpreted versus compiled. Okay, so one way I would say the difference between these two is, let's assume you get a book written in Chinese. Okay, and you don't know how to read Chinese, and you want to read the book. Okay, so there are two ways. One is you can have that book translated at once into English, and you get a copy and you read that. Okay, so that's compiled. That's one way to see what compiled means. The other way is you can have someone sit next to you. He's going to read that text, and he's going to translate that for you line by line. Okay, so that's interpretation. Okay, that's interpreted. Okay, so that's one of the ways I would say the difference between interpreted language versus compiled language. Okay, there are deeper meanings to that, but in general, interpreted languages which are interpreted, which processes the program a bit at a time, are generally slower than compiled languages. Okay, compiled languages will be something like C, C++, and so on, right? Though that gap is bridging. Okay, so that slowness with interpreted language is not not a bottleneck, or at least that bottleneck is going to be resolved over time. Okay. Dynamically typed. Okay, we're going to talk about that in one of the examples. I think in other languages you have to define your variable type. For example, if you call a variable, say type list, or sorry, type integer, for example, right? You cannot change that to say type string, okay, or something like that. Okay, so that's but in Python you can. Okay, so you can call you can assign an integer to a variable, and then you can later on assign a string to that variable or a text to a variable. Okay, and the best part is the Python is the easiest language to read. Okay, it requires it's almost like English. Of course, it's not exactly like English, but it's almost like English as to what you would want your computer to do. You just tell it to do in the language the computer would understand, and you would use Python to do that. Okay. Over to Jupyter. Okay.